The purpose of this video is to compare results of coarse mesh and medium mesh. And the coarse mesh is the mesh we have generated earlier. And the second mesh, which is the medium mesh, I have generated by changing the number of nodes along the boundaries of these walls. And typically speaking, the change should be around 2 times of the first mesh. And from here, if this is around 4 lakh nodes, so second mesh should be around 8 lakh nodes. But 7,21,000 is almost 1.75 times of the first mesh. And it's not necessary to always have exactly twice the size of the first mesh or second mesh. So might be in the next mesh, which is assignment for you, which is a fine mesh, you can generate mesh around maybe a 1.2 million to the 1.6 million, and that will be sufficient. And the idea is that the mesh should be almost double the size of the previous mesh. And you can see the difference between these meshes. We have this is our coarse mesh, and here is the fine mesh or the medium mesh. Right now it's a fine mesh compared to this coarse mesh, but it's a medium mesh. We call it the medium mesh. And you can see number of nodes along the normal direction and radial direction for this first mesh and second mesh, and the mesh along this 9 degrees band. So you can see the difference between these two meshes. And what I'm going to do is that I'm going to compare two things. One is the velocity and pressure along the center line of this vertical pipe, where after the flow is developed into some flow with the separation. And secondly, I'm going to compare velocity at the outlet face, like these are outlet faces, and I'm going to compare the velocity at the outlet faces. So first of all, I'm going to open the medium mesh, and from here we have the velocity equal to 1.0515, and I'm going to store this result in some Excel file. So I just copied this result from here and pasted here in the Excel file. And now I'm going to close this file because we have the license limitation, and we cannot open maybe more than 2 things at a time. So I'm going to close these all things, and also these meshing applications. And now I'm going to open the result file from this fluid flow for the coarse mesh from solutions. This is the cell number A6 is when you double click on here, this will open results file of Fluent in CFD post, and this is the topic of the next section on the post processing of results in CFD post. Right now we are doing everything inside the Fluent's own capability for post processing. And also now I'm going to, from results, I'm going to reports, surface integrals, and it is going to be the mass weighted average and velocity and at outlet, and copy this value and paste it in the Excel file. This is for the course file. And you can see the difference between these two files, these two results, is almost negligible. And why? Because the coarse mesh, according to if you take a look on the coarse mesh, this mesh has sufficient density and refinement of the mesh in the normal direction or radial direction, and as well as along these curvatures and these boundaries. So we expect that these results should be comparable to any fine mesh we will create. So if you want to have some changes in the result that you want to see with the mesh, so I would suggest that you can, instead of refining the mesh to the 4 lakhs and 8 lakhs and then 16 lakhs, I would suggest that you should coarsen mesh from 4 lakhs to 2 lakhs and then 1 lakh, and might be you can call the 1 lakh mesh as a coarse mesh, 2 lakh nodes as a medium mesh, and mesh with the full length, which is this current mesh, you can call this mesh as a fine mesh. So any three meshes will do the job. And so these numbers are arbitrary numbers, and we choose them based on our knowledge and experience. So from here, from results, you can see that there is no change between these two meshes. So it is expected that with a more fine mesh, that is around 1.4 to 1.6 million nodes, we don't see any much change in the result. So I would suggest, this is my recommendation, that you should create the two more meshes with the low density and call this mesh as a fine mesh, and mesh with around 2 lakh nodes as a medium mesh, and mesh with around 1 lakh nodes as a coarse mesh, then compare them. But I would continue with this setup. And so we have found these two things. And now I'm going to open geometry. And why? Because I need the center line of the geometry, and for that I need the coordinates. But I know the coordinates because I have created the geometry from scratch. And if you take a look on this geometry, this pipe length is 20 meters. This pipe length is 20 meters and the radius of curvature is 0.75. So total distance from pipe first and inlet to this center point would be equal to 20.75. And the distance of this face from the origin is going to be equal to 0.75 because radius is same 0.75. So it means that I'm going to create the line. First point would be at the x is equal to 20.75 and the y is 0.75. And second point would be the same. This is not x, this is z location. So same z, which is 20.75. And the y also would be equal to 20.75. And therefore I'm going to create this line in the first for the coarse mesh and then for medium mesh. And that is done from here in the create a line or rake, and I'm going to put the for x as 0, and for y I'm going to put the value of y as equal to 0.75 for the first point, and z would be equal to 20.75, and second point the z will be same, which is 20.75, and but the y now will be equal to 20.75 as well. And click on create. And now I just want to confirm that this is center line or not for this vertical pipe. So I will just plot this in the mesh. And so I'm going to not plot these walls of this vertical and horizontal pipe. So I'm just going to plot this line here. And so click on create also. And line number 10, line number 10, 9, 9 is there. They are duplicated. And if you want to delete the one of them, so you can go to manage and from here delete the one of them. And now just display this line on this display unit and in the graphics window. So you can see this line. And also display unhide the hide from the point from display. And so now you can see that we have this line, and if I plot the outlet face, so you can see this is starting from this end of this pipe, this 90 degrees bend, and it's starting from here and it's ending at this outlet face. So we have created this line, and now I'm going to create the XY plot of velocity and pressure. And because we are plotting along the y-axis, because line is vertical and it's along the y-axis, so I would put the x and z as a 0 and y is equal to 1. So static pressure and direction vector. Choose line number 9 and plot. This is the plot of the static pressure along this line. And you can also plot the velocity from here. It's the velocity plot. And if you want, you can also change the axis and curves. And especially I would go for the change of the curve here. Apply and plot. And from here you can also change the color of the line and these dots, these markers. So let's say I can change the color to the dark blue. Apply and plot. And same is true for the line. You can put any color of your choice. And from here you can also change the thickness of the line, and also you can change the thickness of these markers. So maybe 0.5 for these dots, and plot. This is what we have for this case so far, for the medium case. And now we'll go for the, before that I'm going to write these two files. One is the velocity, and I call this as the velocity course, and I will copy them in the main folder, velocity and course. Okay. And similarly I will choose pressure from here, and first I will plot it and then I will write it to the file, and this is going to be the pressure course, and click on OK and close. And now close the Fluent application from here, and now you'll open the solution from the medium mesh, and so double click on the B5 cell here, and this will open the Fluent results for the medium case. And with the same process I'm going to create the line, and then I will plot data on that line. So I'm going to create the line, and that line will be at the y is equal to 0.75 and z is equal to 20.75, and y1 would be equal to 20.75 and the z1 will be equal to same 20.75, and click on create. And now plot xy plot for the velocity and as well as the pressure. So 0 for the x and for the y is equal to 1. And first I will plot on the line 8 for the pressure. And now we can compare this result directly on this screen, or you can output this data and open the Excel. And for the Excel part, which we did earlier also in the previous workshops, so I'm not going to do that thing. This is the left for the exercise, and you can take on yourself. And I'm going to load the file from here. And first I load the pressure file for that course mesh. So I can file type to the all type, and from here I'm going to read the pressure course, because right now we have plotted pressure for medium mesh. So read this file and plot, and you can see the difference between them is almost negligible. So we can say that we have already achieved the mesh independent study with the coarse mesh and fine with the medium mesh. And when you go for the fine mesh, you will see the no change at all, because if we are not getting any change between the coarse and the medium mesh, so how it's possible to get the difference in results with the finer mesh? And similarly, I'm going to plot velocity on the same line and delete this data from here. So free data, and I'm going to load again the second file, which is my result for the velocity on coarse mesh. Okay, and plot. And again you can see the for pressure as well as for the velocity, there's no much change in the results, and all these gradients and the curvature they are captured properly for both meshes. And so my recommendation would be that you should go for the lower sizes of the mesh, like I told you, 2 legs and 1 legs, and in that case you can see the difference between the two meshes or three meshes. So this is all about the results and how to apply mesh independent study in Fluent, and inside in fact this is inside the workbench. So with the combination of Ansys meshing, where we refine the mesh, and then we run the case in the Fluent, and then we get the results and compare them on two different ways. One is for the some integral quantity, and second is on the local quantities along the some lines. And this can be done for any case you encounter in the CFD field.